Welcome back to another deep dive from Peaceful Rooster Experience.
Yeah.
Today, we are going to talk about the Apache Spark paper.
Oh, cool.
It feels like these days we are practically swimming in data.
Yeah. Yeah.
Every click, every sensor reading, every purchase,
Huh.
it all just generates data.
It really does.
But raw data isn't very useful on its own right.
Right.
We need tools to make sense of it all. And that's where Apache Spark comes in.
That's where it comes in. And what I think is so fascinating about Spark is that it's not just like a faster way to process data. It's like it fundamentally changes the game by acting as this unified engine. Before Spark, if you were working with big data, you often had to juggle all these different like specialized tools, one for batch processing, another for real-time streaming, yet another for SQL queries. It was a real headache.
Yeah, I can imagine.
Spark brings all these capabilities under one roof, which just streamlines the whole process and makes it so much more efficient.
So it's like having a multi-tool instead of a whole toolbox.
Yeah.
That's pretty handy. But I'm curious, like, what makes Spark so much faster than those older systems?
Yeah, so one of the key innovations is the way Spark handles data in memory. Instead of constantly reading and writing data from disk, which is really slow, Spark tries to keep as much as possible in the computer's RAM, which is way faster to access. It's kind of like having all your frequently used files open on your desktop instead of buried deep down in your file system.
Oh, that's a good analogy. That makes a lot of sense.
Yeah.
But what happens when the data is just too big to fit in memory?
Yeah, that's a good question. Even then, Spark is very clever about how it manages the data storage and retrieval. It uses something called a resilient distributed data set, or RDD, which is basically a really smart way to distribute data across a cluster of computers
Yeah.
and process it in parallel.
Okay, so RDDs help Spark handle those massive data sets. But I'm a little bit of a visual learner. Can you give me like an example of what this looks like in practice?
Absolutely. Imagine you have this huge log file
Hmm.
with website traffic data, and you want to count like how many visits came from each country. In Spark, you would create an RDD from that log file and then apply a series of transformations. So you'd map each visit to its country of origin, then group by country, and finally count the visits in each group.
So instead of writing like a complicated program
Hmm.
with loops and conditions and all that,
Yeah.
you're just describing the steps of that data analysis to Spark.
Exactly. You got it.
Okay.
And here's where things get really interesting. Spark uses a concept called lazy evaluation. So it doesn't actually perform these transformations right away. It waits until you actually need the results.
Oh, so it's like a strategic planner.
Yeah.
Figuring out the most efficient way to get things done before jumping into action.
Yeah, exactly.
Yeah, that's pretty cool.
This lazy evaluation allows Spark to optimize that entire data flow. Like, for example, if you only need the top 10 most visited countries, Spark can figure that out early on
Yeah.
and avoid processing data for all the other countries.
Oh, wow. That's really smart. It's like Spark is thinking ahead and saving you time and effort. But what if something goes wrong? What happens if one of the computers in your Spark cluster crashes in the middle of processing?
That's a crucial question. And this is where Spark's fault tolerance comes in. It uses a mechanism called lineage, which basically keeps track of all the steps involved in creating an RDD. So if a part of the data is lost because of a machine failure, Spark can just retrace its steps and reconstruct that data from the remaining parts.
Oh, so it's like having a backup plan for your data. No matter what happens, Spark can recover and keep the analysis running smoothly.
Yes.
It's reassuring.
It is. And Spark's resilience goes beyond just handling machine failures. It also applies to like the data itself. So let's say you're processing a stream of data and some of that data is corrupted or invalid.
Uh-oh. That sounds like a recipe for disaster.
Not with Spark. It can handle these situations very gracefully. You can define rules to filter out bad data, or
Wow.
correct errors, or even handle missing values. This ensures that your analysis remains accurate and reliable, even when you're dealing with like real-world data that's not always perfect.
That's awesome.
It is.
It's like having a built-in quality control system for your data.
Exactly.
That's great.
Yeah.
So we've covered a lot about how Spark handles data efficiently and how it can even recover from errors. But I'm curious about how Spark actually fits into the larger data ecosystem. Like, how does it work with different data sources and storage systems?
Yeah, that's a great question. And it's actually one of the things that makes Spark so powerful. Its ability to integrate with a wide range of storage systems. It's not limited to just one type of data storage.
Oh, that's interesting. So it's not like stuck with just one way of doing things.
No, not at all. Spark can work with data stored in like traditional file systems like HDFS,
Yeah.
cloud storage like Amazon S3, NoSQL databases like Cassandra, and even message queues like Kafka.
Okay, so it can handle pretty much anything you throw at it.
Pretty much, yeah. This flexibility is really crucial because data today lives in so many different places.
Yeah, that's true. So it's like Spark is this like universal translator for data,
Mm-hmm.
regardless of where it's stored.
Exactly.
That's really cool. But how does that actually work in practice? Can you give me like a real world example?
Sure. Let's say you're a financial institution and you want to analyze customer transactions to detect potential fraud.
Okay.
You might have like transaction data stored in a relational database, customer profiles in a NoSQL database, and then like real-time market data streaming in from a message queue.
Okay, so you've got data coming from all over the place.
Yeah, exactly.
It's like a data symphony.
It is. It's a lot to handle.
Yeah.
But with Spark, you can pull all of this data together seamlessly. You could use Spark SQL to query the transaction data in the relational database,
Okay.
access customer profiles from that NoSQL database, and then join that with the real-time market data to create a comprehensive view of each transaction.
Wow, so Spark is like the conductor of this data orchestra, bringing all these different instruments together.
That's a great way to put it.
That's pretty impressive. But how does it actually make sense of all this data to like detect fraud?
That's where Spark's machine learning capabilities come in. You can use Spark's MLlib library to build a machine learning model that learns from historical fraud patterns and then uses that knowledge to identify potentially fraudulent transactions in real time.
So it's like a digital detective,
Yeah,
constantly on the lookout for suspicious activity.
exactly.
That's awesome. But what happens when it flags a potentially fraudulent transaction? Does it just like send out an alert?
It can do that, but it can do much more. Spark can be integrated with other systems to trigger automated actions. Like, for example, it could automatically block suspicious transaction, send a notification to a fraud analyst, or even adjust a customer's risk score in real time.
Wow, that's incredible. So it's not just detecting fraud, it's actually taking steps to prevent it.
Yeah, it's a very powerful tool for fraud prevention.
No. It sounds like it.
Yeah.
And it seems like we've only just scratched the surface of what Spark can do.
Great. We haven't even talked about Spark streaming for real-time data processing,
Right.
or GraphX for graph analysis, or the ever-expanding ecosystem of third-party libraries and tools that extends Spark's functionality even further.
It's mind-boggling to think about all the possibilities. But with all this power and flexibility, what are some of the challenges or limitations of using Spark?
That's a great question. While Spark is an incredibly versatile tool, it's not a magic bullet. One challenge is that Spark's performance depends heavily on how well it's configured and tuned.
So you need someone who really knows what they're doing to get the most out of it.
Exactly. It's like a high-performance voice car. You need a skilled driver to push it to its limits.
That makes sense.
Another challenge is that while Spark supports a wide range of data sources, integrating with some legacy systems can still be tricky.
So there might be some compatibility hurdles to overcome.
Yeah, especially when dealing with older systems that weren't designed with big data in mind. And of course, like any complex technology, Spark has a bit of a learning curve. It takes time and effort to master its concepts and APIs.
Yeah, that's understandable. But even with those challenges, it seems like the benefits of using Spark far outweigh the drawbacks.
Absolutely. Spark has revolutionized the way we process and analyze big data. Its speed, scalability, versatility, and ease of use have made it the go-to platform for a wide range of data-intensive applications.
So what's next for Spark? What does the future hold for this game-changing technology?
Well, one thing's for sure, Spark is not standing still. It's constantly evolving and improving.
Yeah, I'm eager to hear about these developments.
One major area of focus is making Spark even more intelligent and automated.
Oh, interesting.
Yeah, this includes like leveraging advancements in AI and machine learning to simplify tasks like data cleaning,
Right.
feature engineering, and model tuning.
So it's like they're trying to make Spark even smarter.
Right. The goal is to make Spark's power available to anyone who needs to analyze data, regardless of their technical expertise.
So we might see Spark becoming more user-friendly and accessible to like a wider audience.
Exactly.
That's exciting. What other advancements are on the horizon?
Another key focus is improving Spark's ability to handle even larger and more complex data sets. This involves ongoing research into areas like distributed storage, query optimization, and fault tolerance.
So they're constantly pushing the boundaries of what's possible with big data processing.
Absolutely. And with the explosion of data from the Internet of Things, social media, and other sources, this is more important than ever.
Yeah, it seems like we're just generating more and more data every day.
We are.
It sounds like Spark is well positioned to remain a leader in the world of big data for years to come.
I believe so. And as we continue to generate more data, Spark will play a crucial role in helping us extract meaningful insights, make better decisions, and ultimately shape a better future.
Well, this has been an incredibly insightful deep dive into the world of Apache Spark.
It has. And I hope our listeners have gained a deeper understanding of this remarkable technology and its potential to transform the way we live and work.
Before we wrap up, let's recap the key takeaways from our discussion.
That's good.
We started by talking about how Spark acts as this unified engine, simplifying big data processing by handling a variety of tasks that used to require separate tools.
Right.
We also discussed how Spark's in-memory processing and resilient distributed data sets, or RDDs, allow it to handle massive amounts of data with impressive speed and efficiency.
And we talked about how Spark integrates seamlessly with various storage systems, from traditional file systems to cloud storage and NoSQL databases, making it incredibly versatile and adaptable.
We also touched on Spark's machine learning capabilities with MLlib, which allow it to be used for tasks like fraud detection, personalized recommendations, and predictive analytics.
Yeah, and we even peeked into the future a little bit, discussing how Spark is constantly evolving to become even more intelligent, automated, and capable of handling the ever-growing volume and complexity of data in our world.
It's been quite a journey exploring the world of Apache Spark.
It really has.
I feel like I've gained a much deeper appreciation for this remarkable technology and its impact on so many different fields.
It is fascinating to see how Spark is being used to solve real-world problems in areas like healthcare, finance, e-commerce, and scientific research.
And it's exciting to think about the possibilities that lie ahead as Spark continues to evolve
Yeah,
and push the boundaries of what's possible with big data.
absolutely.
Well, before we say goodbye,
Yeah.
let's leave our listeners with a final thought.
Okay.
We've talked a lot about the technical capabilities of Spark, but at its core, Spark is about empowering people to make sense of data and use it to make better decisions.
That's a great point. It's not just about the technology itself. It's about how we use it to solve problems, create new opportunities, and ultimately improve our lives.
So whether you're a data scientist, software engineer, a business analyst, or simply someone who's curious about the power of data, I encourage you to explore the world of Apache Spark and see how it can help you unlock new insights and achieve your goals.
I second that.
Thank you for joining us on this deep dive into the world of Apache Spark. We hope you've enjoyed the journey and gained some valuable knowledge along the way.
And until next time, keep exploring, keep learning, and keep sparking those aha moments.
See you on our next deep dive.